Okay, we are now moving on to the next lesson. This is graphs of exponential functions. So what that means is you will have y equals, as we have in all of the equations, equals, instead of x being a coefficient of a, in this case, x is going to be the exponent, which is why it's called exponential functions. Another name for this is the power curve, because it will always, it's the power, x is to what power? To the x power, so it's called the power curve. So, when we look at this, a has to always be positive. X can be positive or negative like we've had in any of these equations. When we look at the shape, again, this is going to be significant because you want to know what it's going to look like. So when you've plotted the points, you know if you've made a mistake or not. It's going to always look like this. Y equals a to the x will always be going this way, and the y to the negative x will always be going this way. You can see this is the positive. We always have, this is the angle of a positive line, and this is the angle of the negative line. So if the x is negative, it will be a downward slope. If it's positive, it will be an upward slope. So there is no real difference between these and the other equations and the functions, because what we want to do is plug in values for x and plot them. So we can look at an example of this. If we look at y equals 2 to the x power. Oh, something else I wanted to mention actually is that if you notice, both of these functions both go through the point 0, 1. They will always go through that point because if x is 0, it's on the y-axis, anything to the 0 power is always 1. So all of these functions will always go through this point. So if we look at this and if we say, let's look at the values of x between -2 and +4. So we have -2, -1, 0, 1, 2, 3, and 4. So if these are x values, and we want to say 2 to the x, and then we will have our y. So remember, we're not adding in the x value, it's just going to be given to us. So make sure you don't add that column when we're adding these together. Okay, so if we look at this, we have 2 to the -2 power. That's the same thing as 2, if we look at our negative exponents, that means it's going to flip into the denominator. So it's like 2 squared, but it's going to be 1 over 2 squared, which is 1/4. That's 0.25. So the negative exponent, remember, means the reciprocal. So if we have 2 to the -2, it's the same thing as 1 over 2 squared. This is like flipped, this negative flips it, it's the reciprocal. So that could be something to be aware of so you don't make a mistake. This one, we have 2 to the -1 power. If we look at that, we know that this negative is going to flip it. So it's going to be 1 over 2 to the 1 power. Well, 2 to the 1 power is 2. So it's 1/2, which is 0.5. 2 to the 0 power, which we said a minute ago, anything to the 0 power is 1. So this is going to be 1. If we have 2 to the 1 power, 2 to the 1 power is 2. 2 squared is 4. 2 cubed is 8. And 2 to the 4th is 16. So these are the points that we found to plot. Again, we want to use these x and y points, so we won't need any quadrants beneath the x-axis because these are all going to be positive. So that'll save you at least some counting and some drawing. So if we got a -2 and then 0.25 on the y, so I counted by 1, so half of half. Didn't do a very good job of spreading this out very well. -1.5. 0, 1. Again, we said that's always going to be a point. 1, 2. 2, 4. 3, 8, and 4/16. So you can see anytime we have an exponential function, it increases very quickly, and it will also decrease just as quickly because the values make it change so rapidly. So again, we want to do the best we can to draw a smooth curve through the points. And that's what you have in this unit, and so go ahead and get going on it.